All right. Hello, everyone, and welcome to our September webinar. My name is Elise, and I lead the growth team here at Yhat, and I'm joined today by these guys, Colin Ristig, who's our Rodeo product manager, as well as our co-founder and CTO, Greg Lamp. So if you aren't familiar with us already, obviously you are somehow because you seem to find yourself here, but I'll give you a little overview of who we are, and then we'll go ahead and start with the product demos. So we're Yhat. We have three of us on the line today, but we're a company based out of New York, and our focus is on helping data scientists. And a couple of our products that you may or may not be familiar with, but you definitely will be in the next half hour. Rodeo, that's our data science IDE. Hopefully you guys are already using it or will be after this, but it's for anyone who writes in Python code or wants to get started doing that. Our other product, ScienceOps, this is actually our flagship product, and it's for companies who want to deploy their algorithms into production apps. So we'll show you that today with a peer recommender model. And other things we do, places you might know us from our blog. If you don't subscribe to that, you can get updates about 2 or 3 times a week. Everything machine learning, data science, engineering related. You might also know us from ggplot, package for plotting in Python, or might have found us from Twitter, pretty active on there as well. Just a few housekeeping things before we dive in. This webinar, it'll be about 25 minutes long. We'll save time for Q&A at the end. You can send me any questions that you have in the bottom of your screen. You should see moderated chat, and we'll get to that at the end. Otherwise, I will turn it over to Colin, and he'll start by walking us through a product demo of Rodeo.
Thanks, Elise. So as Elise mentioned, I'm the product manager for Rodeo. Rodeo is an IDE for doing data science or data munging related tasks that's installed locally on a desktop, so Windows, Mac, Linux, etc. Just as a brief history, we released Rodeo just a little over a year ago. We rewrote it this past summer to basically help with stability issues. And then we've been pushing out new features quite quickly, some of which I'll go over today. Then looking ahead, pop-out plots, that's what the feature release for 2.3, which is today. I'll show you guys that. We're going to add pop-out capabilities for all sorts of different features. So dataframes is a popularly requested one. And the last thing, a couple weeks out, is we're going to start supporting SQL. So you'll be able to use Rodeo to both execute SQL queries on a remote SQL database, and then take that data and take it into a Python session if you want. So with that, I'll jump into Rodeo and kind of show you some of the new features. So this is the UI for Rodeo. On the left, you can see we have our text editor up here. I can run commands and write code. This is all built on Atom, which is a popular text editor. To run code, I can do 2 different things. I can type command return on my keyboard. That's going to send code down to the console where it'll execute. I can also optionally click the button run line, and I can keep clicking to propagate the cursor down line by line. Run script does what you think it does. It runs the entire script. One of the new features that we've just added in this release is setting working directories. So I can click this bottom tag down here. It'll show me my working directory. In this case, it's set up for Greg's demo. But I can do that all within the UI now. Same thing with clearing the console. I can interrupt code execution with this interrupt button here. Kind of continuing down, so we also just recently added a package search tab. So if I want to search for, let's search for one of our plotting library packages, ggplot. All the results are printed out here, licensing information, the docs pages, as well as other relevant packages. If, for example, I misspell it, we'll show you the top search results for all the packages on pip there as well. So the next big feature for this release is pop-out plots. So in order to make a plot, I'll execute. This is the code you see on the left right now is just a sample script we ship with. And you can see we've just generated a plot. What I can do from here is click this kind of expand arrow. And what that does is it basically generates a brand new window where all of my plots are stored. So imagine you're on a multi-screen setup, which we're not for difficulties with webinars. But you can see if let's change this to green, second plot, and I can see here we've got an additional plot, so I can compare them in the same screen. And just another feature to let you kind of customize your workspace for whatever task you may be doing. The goal, again, as I mentioned previously, is to take this pop-out functionality and apply it to data frames. So if we look at the data frame that I created in the sample script, this button up here, again in the right, will let you pop that out into its own window where it can then be moved around your screen, and you can configure your layout as you like. And the last thing I'll show you, we've added some more tutorials on the sidebar. So if you're getting started with doing Python or anything like that, you have access to a whole bunch of kind of example scripts that we include in there. Documentation, any feedback or help questions that you may have or issues that you find, you can use these icons in the bottom right. And please do, they all inform what we're building and fixing issues. So that's basically a high-level overview of Rodeo. I encourage you guys to go download it. You can find it on our website pretty easily. And we're going to be pushing the update with pop-out plots momentarily. So if you wait 30 minutes or so, we'll shoot you an email when it's ready to go. You can download it. So with that, I'm going to hand it over to Greg, and he's going to show you guys how to deploy into an application using ScienceOps.
All right, thanks, Colin. Jump back over to my slides here. Okay. There we go. So Colin just walked you guys through ScienceOps. I'm going to be walking you all through, or excuse me, he just walked you through Rodeo. I'm going to be talking about ScienceOps. So ScienceOps is our enterprise solution for deploying predictive models. It's used in a variety of industries, anything from alternative energy to education or financial services. And doing anything from recommendation engines, building risk and fraud detection systems, to pricing engines and deep learning algorithms. So for the demo today, I am going to show you all how to take a recommendation engine. In this case, it'll be a fun one. It's going to recommend beers. I'll deploy it onto ScienceOps, and then I will walk you through things you can do with it, how ScienceOps help you manage different models that you have deployed, and we can talk a little bit about the architecture and scalability that ScienceOps provides as well. So to start it, I'm going to jump back over into Rodeo, and for the actual demo ScienceOps model, what I'm doing with this script is taking a series of beer reviews. So let's take a look at those right here. I'm going to come over to my Environments tab in Rodeo, click on my data set, click on my data set file here. There we go. see what you did there. Sorry, Colin's screwing with my script. I was wondering why chickens were coming up in my beer data set. Okay, here we go. So what I've got is a data set that contains about a few 100,000 beer reviews. A review it's sort of like a Yelp review or a restaurant review, but for this case, it's for a beer. So I've got around 600 different beers. I've got a few thousand users that are all from the beeradvocate.com website. So they provided with us with some ratings and some preferences about which beers they like. And what I'm actually going to do is take that data set and do a little bit of Python and NumPy and Pandas trickery and create a recommendation engine that will use that data set to make predictions about or suggestions about beers that someone might like. So what it's actually going to be doing is reading in that data set, building what we call a distance matrix. That distance matrix will calculate the similarity pairs between each different beer. So, for example, for a beer like Budweiser, we'll have the sort of a score or a coefficient for how similar Budweiser is, or how similar the ratings that our users are providing are for Budweiser and every other type of beer in our data set. So what that winds up looking like is a really big a really big matrix where we've got a whole bunch of beers and then a whole bunch of coefficients. It's a lot of data, kind of hard to conceptualize, but just sort of keep it in mind for what we're about to do, which is one part. And what the next part is actually being able to calculate the recommendation. So we're going to create a function called getSims or getSimilarities. And what this does is it allows me to specify a list of beers. So in this case, I've got Sierra Nevada Pale Ale. Maybe I'll add the Dogfish 90-minute IPA to my list as well. And what this is doing is it's filtering out so that we're only looking at the similarity calculations for this set of beers. And then it's averaging those ratings together and then sorting them or ordering them in a prioritized list, so we have the most relevant or most similar beers to these two at the top of the list and the least similar ones at the bottom. So what that's going to allow us to do is to actually make and calculate recommendations so that ultimately when we have someone who wants to input some arbitrary beers and figure out what they might like to drink, our algorithm is going to be able to make that calculation. So the next step, and this is the ScienceOps bit, is actually figuring out how to take this recommendation engine and deploy it. And in this case, a deployment means taking that algorithm and turning it into an API endpoint that can be integrated with other applications. So to do that, we'll import our Yhat Python package. Just so you guys know, we also support R, and it looks relatively similar, but obviously for the demo, I'm using Python. So I'll import my Yhat package, define a recommendation class, which is a type of Yhat model, and then really simply, I'm going to fill out one function called execute. And execute is going to actually make a prediction using the incoming data points from my model. So what it'll do is it'll look at beers that someone has indicated they liked. It'll run our getSimilarities function, and then it's going to return back that list of results so that we can use them via the API. So pretty simple class, pretty simple function. to actually deploy it and send it off of my computer here and up to ScienceOps. Really easy. Fill out my username and API key, and then execute the deploy command here. And what that's going to do is that it's going to transfer my model over to our ScienceOps server. And during that transfer, what's going to happen is that all of my dependencies, all of my functions, requirements, any modules or helper functions I'm using, they're all going to get unpackaged and transferred over to our ScienceOps server. So what you can see here is I've got a few different models that I've deployed already. We'll take a look at the beer recommender, the latest one that I just deployed. And what you can see here is that it's online. We've got version 14. And what's happened is that we've taken that recommendation algorithm, that recommendation engine, we've sent it over to ScienceOps. We've mimicked the environment, so we have an exact replica of my laptop running here on our ScienceOps server. And we've created a JSON endpoint that allows me to send in arbitrary data into my model, and then I'll get results back from actually executing my Python recommendation engine and getting those results back as a JSON data type. So it's a pretty simple API, but it's actually quite powerful because given its simplicity, you can integrate it with pretty much any other, whether it's a programming language or a web application or a back-end process or even something like Salesforce.com. It's super easy to plug this model or this endpoint into another application. I can actually show you a really quick example here. So we've actually got a simple JavaScript application running on beers.yhathq.com. Feel free to visit it if you want to get some of your own beer recommendations. But what it allows you to do is input some different beers that you might like. So I'll plug in a few that I've had before. And then when I click go, what's actually happening behind the scenes is that this website is calling the ScienceOps API. It's generating the results for my model. And then, as you can see, they're getting returned back from within the application. And we're doing a little bit of fancy JavaScript just to display the different recommendations that came back. So it's a pretty logical recommendation from my model. I've input a bunch of sort of hoppy, bitter beers, and it seems to be spitting back some good recommendations for me. This one in particular is pretty good, I know from experience. So that's kind of the nuts and bolts of the ScienceOps API. In addition to providing just like the raw API endpoints, ScienceOps also tracks and versions each deployment that you make for a given model. So in the case of my beer recommender, you can see that I've got 14 different versions that I've deployed over, whether it's different webinars or different demos, but also different algorithms or different strategies that I've employed for making recommendations. Each one of those versions is tracked. We have the actual dependencies of the code that's running. So in the event that I upgrade my Pandas, the version of Pandas that I'm running, my model's not going to break. Everything's going to be, all my requirements will be pegged. All my dependencies are locked in. So I don't have to worry about anything like that. In addition to that, if I ever wanted to roll back or switch to a previous version of my model, that's very easy to do. Each version, there's an artifact that's created for each version. So if I wanted to, let's say, go back to version 11 of my model, I could click this redeploy button, and as you can see, we're going to rebuild version 11, bring it back online, and there won't be any downtime or any latency while we're doing the switch. Everything's a hot deployment. There's never any downtime. So you're still going to have that high availability while still getting the ability to roll back and track and manage different versions of your model. So in addition to sort of this model level metadata tracking, ScienceOps also can track the input and output data that your models are generating. So if I go over the predictions tab here, what you'll see is that we're actually tracking the incoming requests that are being made to each model. So you can see in the past few days, you've had about 100,000 predictions. It looks like there's a few spikes of activity and traffic during that time. I know we were on Hacker News at one point last week, so maybe that's what some of these are. But in addition to getting that kind of that raw summary data, also drill down and actually inspect and see individual predictions that are made on ScienceOps. So in this case, you can see it looks like this was one of the sample predictions I was making for the recommendations, or for my own recommendations, and then actually seeing the results that are coming back. So it's super handy for things like auditing or being able to kind of go back in time and see why a certain prediction was made or what the actual data looked like, and giving you the ability to replay those decisions at a later date. All right, so one last thing that I'll just briefly cover. We had a couple questions come in on this topic, but ScienceOps is built as a clustered architecture. So that's a master and then any number of worker nodes. And what that means is that you can add workers to the system as you need additional throughput or as you need to deploy additional models. So a typical setup would look something like this, where you have a master node. That master node is responsible for things like handling new deployments, routing requests, serving the application that you see here, sort of general tasks like that. The workers are designed solely for executing your models. So they're, in the scheme of things, they're fairly dumb, but what that allows you to do is easily add and remove workers to the cluster as you need additional hardware, as you need to have, whether it be like more RAM or more throughput capacity for the system. Cool. Well, I hope you guys enjoyed the demo. We've got some time here. We're not quite at the bottom of the hour. Do you all have any questions or anything that you'd like to hear more about for ScienceOps? Fire away, and Colin and Elise and I will do our best to answer anything.
Awesome. Thanks, Greg. We have got a few coming in. It looks like you guys are keeping them coming. So I will get started. Looks like one from Mustafa, can I use it with PySpark? Just asked you if you meant ScienceOps or Rodeo, and you said both. So if you guys both want to tackle that, can Rodeo be used with PySpark or can ScienceOps?
Sure. ScienceOps, I'll start with ScienceOps. ScienceOps can be used with PySpark or any other Python library. The system is built in a very generic way, so you're not using any special Yhat specific Python packages. So whether it be PySpark, TensorFlow, Keras, MXNet, any of the new and up and coming deep learning or machine learning libraries, those are all work just fine with ScienceOps.
And same thing goes for Rodeo. For PySpark, you would just need to configure your PySpark context, point it to the cluster where that's running, and you should be off and good to go.
Great. Another question, also Mustafa, how easy is it to integrate with AWS?
Yeah, so It's very easy. ScienceOps ships or is distributed in such a way that whether you're running your own hardware or whether you have a data center or if you're on AWS or the Google Cloud or Azure or any cloud provider, doesn't really matter to ScienceOps. It can install on any platform.
Cool. Another question, this one from Kevin. Will ggplot eventually be included in the Anaconda distribution?
You'll have to ask the Anaconda folks, unfortunately.
Hopefully, maybe.
Unfortunately, I don't control that. So that's out of our hands to a certain extent.
Yep. Here's another one we have a little more control of. Kyle asked, this is for Colin about Rodeo. Packages used to show the installed packages that you already have loaded. Do you guys plan on that feature coming back? As well as the new one to be able to load new packages?
Yeah, good question. We will be adding back the like the currently installed packages to Rodeo. We decided that having the search and install functionality was more important, so we kind of scrapped the table for the time being, but we'll likely add it back. Please, if you do have thoughts on how you'd like that to be implemented or opinions, the discussion board for Rodeo is a great place to provide feedback on topics like that.
Sounds good. Here's one from Frank. It came in a little bit jumbled, might be on your cell phone or something. The actual question is server or model, how do we deploy RStudio to? I think what you're getting at is whether you can, like in RStudio, whether you can deploy models from Rodeo onto a server. Probably for you, Colin, or either of you.
So Rodeo right now is installed just on a desktop machine. It runs locally. We have talked about creating a server version for it, but that's not on the immediate roadmap for now.
Cool. Mark, sorry we left you hanging. We tried to address that question. You just wrote in, why didn't you answer the first question? So we'll jump back to that. We can definitely spend a little more time. You said, I have a scikit-learn pipeline. Just as context, this was going back to Greg about ScienceOps. I have a scikit-learn pipeline written in Python that generates sklearn models. Is there any way to get horizontal scalability for model deployment using your product?
Yeah, so we support scikit-learn right out of the box. It's one of the most common libraries that our customers use. In terms of the pipeline, you can sort of think of ScienceOps as the last step in that pipeline. So you could use the scikit-learn pipeline functionality for building and training your model. Once that is complete, you can take the resulting classifier or regression model or ensemble or whatever it is, wrap it in the ScienceOps Python package, and then upload it or deploy it onto the ScienceOps server. So I hope that helps. And then in terms of the sort of the scalability aspect, I touched a little bit on the worker master architecture, but you can scale ScienceOps horizontally just by adding any number of workers. So if you wanted to have, the example cluster I showed had 2 workers, but if you needed 5 or 10 or even 15 or 20 different workers, that's something that you could do via the application.
All right, sounds good. And I've gotten a couple requests for pricing, which we are very excited that you're that interested. We've got engineering team in the room right now, so we won't talk specifically pricing, but I think Greg went through the base architecture by your throughput, by nodes, things like that. And for anyone who is interested, you can just message me and I'll put you in touch with someone on the sales team, and they'll be happy to walk through sort of what your use case is and what you'd be looking to do with the product. If you have any other questions, we are a minute over, but still happy to stay on the line. I'll keep the chat open for a few minutes, and otherwise, thank you all very much for joining. I'll send out the recording probably tomorrow, because today we're going to be focused on pushing out the next version of Rodeo. But otherwise, thank you guys, and have a great day.